Engineering, CSEI Department, Bengaluru. Today, I will give a small presentation on typical ResNet architecture. And now let's move to the introduction of the typical ResNet architecture. Introduction to ResNet architecture. ResNet, which stands for Residual Neural Network. It was introduced by Microsoft Research in 2015. ResNet is known for its ability to train very deep neural networks efficiently. We can call it as one of the greatest efficient methods of the deep learning, where we can use to train the models and get better results than a typical CNN architecture. So we can tell that ResNet stands better than the typical CNN architecture. So which, as I've given, which means residual neural network, and mainly it was introduced and brought up by the Microsoft Research in 2015. So as I've given, it's very much important in deep neural networks, in deep learning mainly. So which helps us to train our models and gives the greater accuracy than the CNN. Residual learning. Traditional deep neural networks suffer from vanishing gradient problems. Residual learning aims to address this issue by using shortcut connections. These shortcut connections allow the network to learn residual functions. So as they have given input node layers, so the inputs which include here are three: input x1, input x2, input x3, and this is the input nodes layer. Next is the hidden nodes layer. So that is the links which we have connected. Every neuron is connected to every other neuron in the hidden layer. We can see that the first input x1 is connected to every other, that is the 4 which is placed vertically, hidden node layers, to every one. It has been connected. Similarly, input x2 and input x3, and it has been again, every node will be connected to every other node in the next layer. So it is connected to the output nodes layer here. So we can see output which is produced y1 and y2 of ResNet. The basic building block of ResNet is the residual block. The residual block consists of two convolutional layers with a shortcut connection. The output of the shortcut connection is added to the output of the second convolution layer. So as they have given, so the basic or the fundamental thing or the basic unit which is built is using the residual block, and mainly it is going to have two convolutional layers. It is like a shortcut connection from one which will be connected, and from that connection it will be connected to the second convolutional layer. As they have mentioned that it is a shortcut connection, so it will be connected, so its output will be connected to the second layer directly. So it is a short way and a better way and an efficient way compared to the other. So this is about the building blocks of the ResNet. Stacking the residual blocks, placing the residual blocks. How do we do that? So ResNet architectures typically stack multiple residual blocks. It mainly tells that we place multiples of residual blocks one on the another. So deeper ResNet models have hundreds of layers. So in order to build a greater task or greater deep neural networks, we'll be stacking the residual blocks having hundreds of layers. Like in hundreds of layers, we are going to place this multiple residual blocks. So stacking the residual blocks allows the network to learn complex features. So by keeping more and more residual blocks, it is going to capture the greater features when we compare to the fewer number of residual blocks. Skip connections. Skip connections in ResNet allow the network to bypass one or more layers. Skip connections help with gradient flow and alleviate the vanishing gradient problems. Skip connections are skip connections enable the training of very deep neural networks. So as we can see that we are going to have the convolution layer there, and we're going to have the skip connections. So we can skip all of these and we can directly move to the other. And from this we can deviate from the vanishing gradient problems. So as we are training, the gradients become lower and lower and lower, so which will create a greater problem. So we can do the skip connection here. So by skipping all of these connections and directly we can move ahead. Instead of directly learning the desired underlying mapping, the residual function is the difference between the input and output of a block. This approach simplifies the learning process and improves the performance. So we have given here the X and the weight layer, and we're going to have it pass through one more weight layer, and this is the identity mapping which they have mentioned here. So it is like we are going to use some of the functions so that we are going to get the required mapping. Types of ResNet architectures. ResNet architectures come in different depths, such as ResNet 18, ResNet 50, ResNet 101, and ResNet 152. Deeper ResNet models tend to have better performance, but require more computational resources. The choice of ResNet architecture depends on the specific task and dataset. Training ResNet models. Training ResNet models requires a large number of dataset and significant computational resources. Techniques such as data augmentation, batch normalization, and learning rate scheduling are commonly used. Pre-trained ResNet models are available for transfer learning on new datasets. Benefits of ResNet. ResNet architectures have been widely adopted in various computer vision tasks. ResNet models have achieved state-of-the-art performance on image classification benchmarks. ResNet skip connections and residual learning concept have influenced the design of other neural network architectures. Applications which we can see for this are image classification. ResNet models are widely used for image classification tasks such as identifying the blocks or the scenes within images. They have achieved state-of-the-art performance on benchmark datasets like ImageNet. Then object detection. ResNet serves as a backbone architecture for many object detection systems such as faster RCNN, YOLO, you only look once, and SSD, single shot multi-box detector. The deep features learned by ResNet are crucial for accurately localizing and classifying the objects within images. Transfer learning. Pre-trained ResNet models trained on large datasets like ImageNet are commonly used as feature extractors for transfer learning. By tuning these models for the domain-specific dataset, one can achieve good performance even with limited datasets. And the conclusion we can come here is the ResNet architecture has revolutionized deep learning by enabling the training of very deep neural networks. The use of skip connections and residual learning has proven to be effective in improving the gradient flow and learning performance. ResNet continues to be a popular choice for various computer vision tasks due to its performance and versatility.